Welcome. In this lecture, we're going to basically explain how you undo the chain rule, right? So the chain rules for differentiation. Integration by parts is going to be kind of the undoing of this, and I'll show you how they are actually connected. This is also one of these tools I'm going to have to tell you many times when you're integrating a product. You can't just integrate this and integrate that, but you'll learn some tools to actually integrate a product. So without further ado, let's get started. So this is kind of, I'll start with going by how we go from the product rule to integration by parts. This is something that I'm going to abbreviate almost always as IBP. Okay, this kind of gets a little tiresome to write it out. So what we're going to do is we're going to look at how do I take the derivative of the product of two functions. So I have a function, so I have functions f of x and g of x, and I've taken their product. Right? And so we've seen this before. This is just the chain rule. I want to take the derivative of the first, multiply that by the second, and then take the derivative of the second and multiply that by the first. Okay? So we have that here. Right, in which order we write these doesn't matter because addition and multiplication are commutative. Okay, but that's one way to write this. And then the next thing I want to do is to actually take the antiderivative of both sides. Okay, so let's go ahead and do that. And if I have the derivative and then I do the antiderivative, I get, my original thing back. So I get f of x times g of x on this side. And this is going to equal, well, here I have to actually integrate. So let's go ahead and just integrate each of these. So I have, or write that I'm going to integrate them. So I have the integral of this term here. It is, right, the integral is additively, it does break apart additively, so it's linear. So I can do this with the integral. With addition, if it was multiplication, I couldn't do this, but because it's addition, I can. And there we go. I've just taken the antiderivative of both sides. Okay, so let me even kind of write that. I'm just taking antiderivative of both sides. Okay, so I took the antiderivative of both sides. Okay. Now that I've done that, I'm looking at this and I see that I'm going to try to solve for this here. Okay. Okay, so I want to solve for this. This is the next thing I'm going to do. So going from this line to this line, I took the antiderivative. Now what I want to do is I want to solve for this. Okay, and I just kind of rearrange things to do that. Okay, so I'm going to get, all I'm doing is rearranging, and I'm going to get that the integral of this, so I have the integral of, I just want it on this side for the sake of the formula looking like I want to look, of this. So this here is going to equal, and then I have f of x times g of x. And then I'm going to subtract off the integral of, right? So I'm just left with, if I move this over, or kept this on the side, I'm going to move this over is really what I'm doing here. So I've got there f prime of x, g of x dx. Let's step a little bit to the side so you can see what I'm writing. Okay, all I did was solve for this, so I moved this to the other side, or subtracted this from both sides, so I ended up with f of x, g of x coming from there, and then this came from, I needed subtraction for when I moved that over. Okay, so all I did was kind of rearrange things. So here I'm just rearranging. Okay, and once I get here, this is actually like my final answer. So let's put a box around this. Okay, so this is a new formula that's very useful because how else are you going to integrate a product? You hope that you have something like this you can do. So let me show you an example. Before I show you the example, we're going to use something, and so I'm going to kind of write it over here. So we're going to use this new, it's not so scary notation. Okay, so we'll use some kind of new but not so scary notation. So let's go ahead and write this. So what is this new not so scary notation? It's going to be that if I write df like this is the word for this is the differential of f. Not the derivative of f, but the differential of f. That this is going to equal the derivative with respect to x of f dx. And the name for this, just so that you know, this is the differential of f. Okay, so we're going to want to use this. I'm going to put this in a box so that we can use it. Okay, great. So now let's go through an example of using this formula. So I'm going to do it right here so that you can kind of see how it lines up. So we have this, here's an example. Okay. So I'm going to want to integrate, and I'm going to very suggestively color code things. So I have x cosine of x dx. So this is going to equal, so, right, you can see, okay, so what's the first thing I need to do? Let me actually kind of sort out what my f of x and g prime of x is and what I'm going to do with them, okay? So I'm going to have my f of x, right, is just x. Okay, so let's kind of put this over here. So I have f of x is just going to equal x, okay? And on this side, right, I'm going to need over here, I'm going to need f prime of x, which is something I don't have yet. In fact, what I really want is df. So let's just go ahead and write that. Actually, I'm going to do f prime of x. So I'm going to take the derivative. No, I am going to write it as df. And then we're going to see some new notation in the next lecture, so that I do want to actually write it this way. So what I'm doing, right, so I look at this, and what does this tell me to do? It tells me to take the derivative of that. Okay, so I do that. And then next to it, I need to write dx. Okay, I can do that. Okay, so what I did here was I took the derivative, right, because I wanted this from over here. Okay, so for this one, I take the derivative. Right, once I've identified my f of x, I take the derivative to find the differential. And then I'm going to want to have my cosine of x is actually a g prime of x. Okay, so let's just write that. What we're going to write then is that dg, right? So dg is g prime of x dx. So that here is actually cosine of x dx, right? Maybe I just can write on here to kind of make this easier to see. This is my g prime of x. You know, you can kind of see how this lines up. This is my f of x. Okay. So once I knew that that was my g prime of x, my dg is equal to that dx. And then on this side, so that for that one I want to take the derivative. This one I'm going to do the opposite. I'm going to take the antiderivative. I'm going to take the antiderivative. And what do I get there? Well, the antiderivative of cosine of x is just sine of x. And let me write this kind of how I'm going to want that written, which is actually is g of x. Okay, now I have everything I need to actually kind of put this into the formula. So I'm going to get, okay, so I need f of x times g of x, so that's going to be f of x times g of x. So I have x And then I have sine of x. And then I'm going to subtract off. And now I want to take the integral of, so f prime of x. So that's right, that's this. So let's put that there. Right. This part here is f prime of x. Right. And then just to be clear, and this part here is g prime of x. Okay. So there's my f prime of x like that. And then I have my g of x, so that's going to be sine of x. And then I have dx. Okay. And now let's just kind of work with this a little bit. So if we look at this here, this is I've got the integral of 1 sine of x dx. Okay, but we all kind of know that that's actually, so what is this? So what I'm actually doing here, so this is the integral, well, this 1, I'm just multiplying by 1, so that really isn't necessary there. And then I need to take the antiderivative, right? I need to take the antiderivative of this, which is actually going to be, if I took the derivative of cosine of x, I would get minus sine of x. There's no minus here. So I need to actually have minus cosine of x, so that when I take the derivative of this, I get minus sine of x, so I get minus minus, and I do indeed get that. Okay, so this would be n plus c. Okay, so let's then write this over here. So this is going to give me, so I'm going to have, I can just rewrite this because this part's already integrated. So I have x sine of x, and then I took this integral here, I got this, so I get minus cosine of x, and I just stick the constant all the way at the end. It's just to kind of collect constants together. We only need one constant at the end. Okay. And so this is then going to equal x sine of x, and then I have a minus and a minus, so I'm going to get plus cosine of x plus c. Okay. And then we box that because we're done. Okay, so let's set everything down so that we can go through what we did. Okay, I was just showing you in the first part how we got from the product rule to integration by parts, but this is the integration by parts formula. Okay, so this is the actual formula. Okay. So once I have the integration by parts formula, I can integrate sometimes a product, and then I'll talk in future lectures about how you know to use this and so on. And so I have, in this circumstance, the reason why this kind of worked, right, is because I could take the antiderivative of cosine of x. And in fact, if I took the derivative of x and then the antiderivative of cosine of x, I got something I could integrate. Okay, and that's something to kind of get used to recognizing. And I'll talk about this more in later lectures. But really the idea is that in some sense, this gets more simple and that stays the same amount of simple in terms of how difficult it is to integrate. Okay, so we went ahead and did that. And once we identified those, right, I have an f of x, and then I want, and I know this looks like I went a little bit overboard. Oh, let's do this in green here so you can see that this is the other part of the differential. I could instead have written that as like g of x times the differential of f. And you'll see me do that in a future lecture, something similar to that, okay? But that's the whole differential. I know that I could just say here that this is f prime of x times g of x. I'm doing it this way to make the notation the next one a little bit better, okay? But the whole idea is that I do take the derivative of this. And for my dg, or my g prime of x, right, I take the antiderivative. Okay, and then I can just put those into the formula. So I have f of x times g of x minus, and then I have the derivative of x times g of x. And I take that integral. And so I went ahead and did that here. It's 1 times sine of x, so that's just the integral, right, of sine of x. I put a minus in front when I'm taking the antiderivative because if I just took the derivative of cosine of x, I would get minus sine of x. So now, so I would have ended up with a minus there. So to kind of compensate for that, I put a minus so that I go minus sine of x. Ah, sine of x, perfect. Okay. So I just put that integral in here. We can just kind of clump all the constants at the end. I could have put it in here and then just been like, oh, clump all the constants because multiplying a constant by a constant or adding a constant to a constant gives you a constant. So you can actually just kind of stick it on the end and not worry about it with integration by parts. Okay, and then I just reduce this down. There's a minus, minus, so there's a plus. That's all I did in that step. So I hope that made some sense, and I'll see you in the next lecture.